I'm now thrilled to introduce Chris Rice from AT&T. He's the Senior Vice President of Domain 2.0 Architecture and Design, and he's responsible for delivering the architecture and design of AT&T's new software-centric network.
All right, good morning, everyone. So I think Neil did a great job laying out kind of what's going on in Open Daylight, the work that other folks are doing, kind of the effort that's happening within the broader industry. I'm going to talk about what's happened within AT&T and history of SDN control at AT&T, which probably goes back further than you think. I'm going to spend most of my time on the more recent stuff, but it's always good to have a sense of where things come from. I'm going to start off with some definitions. That way I won't get into any discussions after this and the break about, well, I really think SDN's this, and I think a controller's this. But SDN's really an architectural approach to network design that adds some type of programmability to the elements, making them more dynamic, making them more manageable, making them more adaptable. The controller essentially is a long-running application in SDN that provides flow management and enables intelligent networking. And it allows us to control where the elements send the packets. But I'm going to show you by the end of the talk that it also provides a framework for us to be able to do VNF management or application control, as well as enabling software control of the optical and wavelength layer of our network. So here's our historical view. So believe it or not, we start off at TDM, and for all those people, too young in the audience to know, TDM stands for time division multiplexing. There was something in the network at one point in time called the network control point. It was actually built on something called the stored program network control. That was a big deal at the time. I was going to make a joke, and I decided not to about 640K being enough for anybody for memory, but maybe this wasn't the right geography to do that. But the interesting thing about this is that, believe it or not, this was the basis for the 1-800 service, so a better way of doing customer care calling. And hearkening back to some of the things that Neela said at the time, no one was really aware about all that growth that would result from that. That was a multi-billion-dollar industry, right? And so, one of the things we might want to ask ourselves, are we on the precipice of doing something like that right now with what we're doing in ODL? Believe it or not, this was something that allowed us to create a virtual network. I actually have the documentation that shows that for our customers. And again, it was called a software-defined, TDM, software-defined network. So I want to talk a little bit about kind of what we did early on in the IP area, the intelligent route service control point, and something that we called router farm. Think server farm, think for routers though. And then I'm going to get into what I'll call SDN Classic, which is the layer 2, 3 stuff and the work we're doing there. But that really forms the framework for what we do in the other areas, in the application controller and in the ROADM, right? Reconfigure optical add-drop multiplexer. Okay, so a router farm. So what we were really trying to do here was remove the static relationship between the edge router and the customer. And the reason for that is that we wanted to be able to provide better resiliency to our customers. We wanted to be able to detect failures, do planned maintenance, backups. And one of the reasons this became very important to us, and I don't know how many years ago this was, a long time ago, one of the routers that we had on our edge, and this is tens of thousands of routers, was going end of life. And there wasn't really a catch product from the vendor for it. So in other words, we couldn't take the configurations that we had that were known working for the customers and put them in another router. And so they said, well, what do we do? And they said, well, you can have a whole bunch of people just kind of rewrite all that stuff, and if you go through and figure out how long that'll take and what you might be a year into a cycle and the errors that could occur, this wasn't something we wanted our customers to go through. So we built a router farm controller that actually allowed us not only to take that configuration, but actually to change router vendors. So we actually took the configuration from one manufacturer and put it into another. And of tens of thousands of routers, only 2 were outside that maintenance window. So very impressive. So it was better, faster, cheaper, but it wasn't really as reusable as we'd like it to be. And so with that kind of early knowledge of what we've done there and some of the work we did in IRSCP, we said, look, what we'd really like to do is to be able to separate the service from the network, from the device that it runs on. That's our goal. And so when we put IRSCP in our network and we did a scaled version of this, we actually helped create some of this technology. We had some key learnings that came out from that because we ran this at scale in our network for many years. And one of them was proper modeling is critical, right? So that abstraction layer is very important. And signaling, while necessary, is not sufficient. You have to be able to think about things like configuration, resource management, and analytics. And so I want everyone to kind of transport back in time about 3 or 3.5 years, because what I'm about to say won't sound so insightful today, but 3.5 years from now, or 3.5 years ago, it was fairly insightful. So we had all that knowledge of what we'd done in the controller space. We had this little thing that was happening in the data centers called virtualization and cloud. You had Intel working on improving the packet performance of their standard server CPUs, which improved about a factor of 100 over 10 years. Then we had people like you and other people in academia and research institutions building software to software enable some of the functions that we needed in the network. And so we came to the conclusion that next generation carrier grade networks must be cloud-based, must be model-driven, and must be software-defined. Again, I told you it wouldn't sound too insightful today, but 3.5 years ago, pretty insightful. So eComp was born, and Neela did a great job for giving us a little commercial there. And so that's enhanced control, orchestration, management, and policy. I'll give one quick slide on that. But really, what I want to talk about in eComp is what the controller's function is with inside it. Again, not just the classic layer 2, 3, but also 4 through 7, as well as the optical layer and wavelength layer. Quick slide on eComp, just 3 kind of takeaways here. 1, you see the controllers there in the right-hand side, kind of middle. That's where I'm going to spend most of my time talking about it. There is a URL at the bottom there, www.att.com/ecomp. You can go there and get some information in the white paper. But the big thing I want to talk about here is really that this is not something that, like Neela talked, this is not something that's a science project. While 3.5 years ago, it was an architecture. It was an architecture that we thoroughly vetted based on some of that knowledge that we had talked about. But today, and for the past 2 years, it's something that we've been using in production. So last year, we virtualized about 5.7% of our network. 5.7 doesn't sound like a lot, but it's a network the size of AT&T's. That's a pretty good amount. And then this year, we have a goal of 30%. So this is something that we have been using in production, growing the code every day. It's about 8.5 million lines of code, still growing in functionality. And we're learning, I cannot stress enough, the amount of extra knowledge you learn as opposed to doing POCs, as opposed to having it in production and getting feedback from people in the field, operations, and other areas. So again, we talked about the controller framework inside of eComp. This is just a representation of that controller framework. It's built on top of ODL. We do have some customization and extensions. Those are shown in green. One of them is outside. That's our active and available inventory. We do a little bit of work in the database and the configuration tree. But one of the big areas that we've done is the service logic interpreter. I'm going to talk about what that does when I talk about the 4 primary components associated with a controller. One is the northbound API handler. So this is essentially the auto generation of those APIs through the MBI Yang using ODL Yang tools, open source with some extensions that we use for remote procedure calls. We have the directed graphs, which are essentially the executable nodes that control the flow of data through the SDNC, and the service logic interpreter, which is essentially a Java engine that allows us to execute those nodes, and then a configuration nodes, which essentially handles the APIs into the devices themselves. So on top of that framework, we build our functionality for those different layers of the OSI stack. So again, one of the key takeaways, if nothing else, you always have a successful talk if there's 3 takeaways. So one of my first takeaways is that we've used ODL and we've used this capability to do all the different layers in the OSI stack. But we also realized that unfortunately, not every developer knows how to program at the low level necessary for ODL. And while it's probably pretty hard to see on here, think of the items on the menu on the left-hand side is widgets that have been built by people who do know how to program at that low level in ODL. And think of the network and service designers as people who are bringing those widgets onto a drag and drop GUI and connecting them the way they need to be connected. This will then generate a model in our service design and creation catalog environment, and then that will then be pushed to that framework that I showed earlier to execute that design. So I think you're gonna hear a lot of talks, and everyone here knows a lot about the layer 2, 3 part of what you can do with Open Daylight. But I want to talk some about the application controller side. What can be done in layers 4, 7? And really the goal of our application controller is to first initialize and configure the VNFs during deployment, to automate that life cycle that they go through as we use them and consume them, and then finally to correct and monitor faults and failures in the application components. So we abstract the cloud, the virtual function or virtual network function interface to do this in a repeatable way. This is done in a vendor and VNF agnostic way, or VNF agnostic mechanism. I'll just repeat that, vendor and VNF agnostic way that this is done. And obviously it allows us to enable the automation to do this. And I promise you I won't go through every one on the bottom left there, each one and what they mean. The reason they're there is that today the VNFs that we get, quite frankly, are too special. They're not really, they're too unique. They're snowflakes. We want more like Lego blocks rather than snowflakes. And I'm giving you an example of a kernel set of commands, quite frankly, that each VNF will need to perform regardless of the function that it performs. Right? We need to be able to configure, test, scale, start, stop, rebuild, restart every VNF. And I promise you that AT&T does not make its buying decision based on the code or the API of that particular function that I just went through. So it's to the whole industry's advantage to normalize those. For SDN really to deliver on what we needed to deliver, that is a key function that has to occur. So again, another big takeaway, move the VNFs from snowflakes to Lego blocks. Now Lego blocks, if you remember them from the old days, if you have kids like I do who used to play with them, they're different sizes, they're different shapes, they're different colors, they're not all exactly the same, but they all interoperate, and that's the key. Again, at the lower layer, the SDN controller, this is some really great work. You see the URL at the upper right there, www.openrotom.org. This is some work that was done by one of our AT&T fellows, Martin Burke, and his team. And essentially what this is an ability for you to bring signaling in on a particular wavelength or on a particular piece of optics, and to be able to change that as you go through the different parts of the network. Now the great thing about this is this is not something that's virtualized. This is a PNF, a physical network function as opposed to a virtual network function. And that really didn't stop Martin and his team though from creating an excellent abstraction of this within Yang. So really well defined, as are the interfaces and APIs associated with it, as is the data telemetry associated with it. So when we talk about moving from snowflakes to Lego blocks, Martin and his team did a really great job in that area, in this area. And this is nice because you can see that there are different vendors who've signed up to be a part of this organization. We've shown that vendors A, B, and C are interoperable in doing this. And so this is something that really facilitates the building of the network and growing of the network, as well as the management of the network now on top of it with the ODL code as well. So lastly, I just want to hit like why Open Daylight? Why have we used Open Daylight? And really, 2 reasons, or 3 reasons I should say, sorry. Controllers and ODLs are really platforms for innovation. Innovation in the network and in the service design. And I went through and showed you how we're leveraging that capability with some of the GUIs and drag and drops that we've done. And we're using that not only for the layers 2, but 4, 7, as well as 0, 1. And we need programmable controllers like ODL to support a rich set of north-south interfaces and capabilities, as well as east-west, and support brownfield protocols. I think that's one of the big reasons that ODL has had some of the success that it has. It recognized the fact that there were existing protocols in the network. It would have to support those as well as new ones. And then lastly, my other big third takeaway from the talk really relates to what we as an industry really need to do. Right, so we've seen a lot of good work. This is, again, not a science project. It's in production at AT&T. It's in production at other places that Neela discussed. But we really need to keep working on reliability and scale, especially geo-redundancy. So my third takeaway is that one. So I want to thank you all very much for the time today, and I'll turn it over to the next speaker. Thank you. Effort that's happening within the broader industry. I'm going to talk about what's happened within AT&T and history of SDN control at AT&T, which probably goes back further than you think. I'm going to spend most of my time on the more recent stuff, but it's always good to have a sense of where things come from. I'm going to start off with some definitions.
I'm now thrilled to introduce Chris Rice from AT&T. He's the Senior Vice President of Domain 2.0 Architecture and Design, and he's responsible for delivering the architecture and design of AT&T's new software-centric network.
That way I won't get into any discussions after this and the break about, well, I really think SDN's this, and I think a controller's this. But SDN's really an architectural approach to network design that adds some type of programmability to the elements, making them more dynamic, making them more manageable, making them more adaptable. The controller essentially is a long-running application in SDN that provides flow management and enables intelligent networking. And it allows us to control where the elements send the packets. But I'm going to show you by the end of the talk that it also provides a framework for us to be able to do VNF management or application control. All right, good morning, everyone. So I think Neela did a great job laying out kind of what's going on in Open Daylight, the work that other folks are doing, kind of the